In this lecture, I would like to explain you purpose of the branches and actually reason for using branches. But before doing that, let me quickly recap what is actually branch. Branch is just text reference to specific commit, and we have discussed it before. Default branch is master, and of course multiple branches can exist in the same repository. Next, all pointers for all branches are located in .git/refs/heads folder, and inside of this folder you'll find multiple files if you have multiple branches, and every file will have same name as branch. Next, current branch tracks new commits, and branch pointer moves automatically after every new commit. And you can check out specific branch by using git checkout command, and here type simply name of the branch, for example master or experimental or temporal or new branch or dev 1512. You can check out any existing branch. But please note that when you create new branch, you cannot use spaces in the name. Use, for example, dashes instead. Okay, that's what is branch. But why do we actually need branches? Let's have a look at this diagram. Let's suppose that you are working on your master branch, and here you see commits made in master branch. But now at some point of time, please notice that timeline is here. So here you see more older commits, and here to the right more recent commits. And let's suppose that at a specific moment of time, for example here, you decide to work on a specific feature, but you don't want to implement this feature directly in master branch, because for example you're not sure whether this feature will remain in your main project, and let's say that master branch is our main project. And at this moment of time, for example here, you decide to create new branch with name BR102, and you start working in this branch. And recap that all commits are made in current branch, and if this branch BR102 is current branch, those commits will be made only in this branch, and master branch will remain intact. But parallel after making this branch, someone else or you may continue working in master branch. And for example here and here you see commits that were made after creation of this BR102 branch. And notice that for example this commit and this commit were made on different moments of time. That's because now those two branches, BR102 and master, are independent, and you can make commits in those two branches at any moments of time. In the same way, we can create another branch, for example branch called EXP, experimental. And this branch was created at this moment of time, after this commit in master branch. And here you see commits made in experimental EXP branch. And again, this branch EXP is completely independent from master branch and BR102 branch. And commits made in this branch don't match in time with commits made in other branches, master or BR102. More than that, this branch EXP doesn't even know about presence of other branches, because you know that each branch is actually just text reference to specific commit, nothing else. Branch simply stores SHA-1 hash of specific commit. That's why branches are completely independent from each other. Here you see branch that was created on the basis of other branch. For example here after this commit, inside of the branch BR102, you decided to perform some tests and create other branch based on this branch. And here you have created branch called temp. And you can make some commits inside of this branch, test some features or something like that. And when you are done with your experiments, you can simply delete this temporal branch. And all commits will be deleted as well. And picture will be like that. Okay, that's what are branches. And in simple words, we can say that every branch is actually separate history of your project. So here is one line, here is another line, here is main line, let's say, it's a master branch, and here is one more line. And you can develop different features in parallel. More than that, if multiple people are working on the same project, they can work in separate branches and they can do their job completely independent from each other. And when specific feature is ready and it is tested and verified, corresponding branch with its commits can be merged, for example, into master branch. We will discuss how to merge branches later on in the course. For now, please keep in mind that every branch is actually separate history line of the project, or let's say separate story. And my recommendation to you, please be consistent in naming conventions for all branches, and if you decide to name branches like this, please use such names for all branches. Or you can use self-explanatory names for the branches. For example, you can create a branch with name, let's say refactor main menu, like that. And this branch name clearly tells other developers what is the reason for this branch. Okay, that's how you can name branches. Next, you see here head pointer, and you know that the head can be only one. There are multiple branches on this diagram, but head pointer is just one. And at the moment it points at experimental branch, exp. This experimental branch is wrapper for this commit. And you know that underneath this commit there is a tree with blobs and probably other trees. And that means that at this moment of time your working directory contains files and folders based on a tree object underneath this commit. And of course, you can easily change version of your project and move to another branch. For example, you can check out branch master. And after checking out, for example, master branch, your head pointer will move to this location. And now this version of the project that this commit points to will be checked out to your working directory and staging area. You can also easily check out other branches, for example, move to this branch, or move back to experimental branch, and so on. And for that you can use git checkout command. And in the previous lecture we have actually checked out different commits. And that's not a preferable way to change versions of your projects. And that is actually another reason for using branches. When you use branches, you don't need to remember SHA-1 hashes of specific commits, for example, this one, or this one. And you can check out different commits simply by using branch names that are wrappers for those corresponding commits. For example, master branch is wrapper for this commit, BR102 branch is wrapper for this commit, and so on. That's how you can change versions of your project using human-readable text names. And recap that, of course, you can check out specific commit, but in such case, when head points to specific commit like this, we allocate it in so-called detached head state. And it's not recommended to create new commits in detached head state. But if you do so and after committing changes move back, for example, to specific branch, those commits that were made in detached head state will be lost and deleted automatically by Git. And you will be able to return to those commits. That's why in most cases head is reference to specific branch, not commit. And again, you can pretty easily change branches by using git checkout command, and after git checkout simply type name of the branch you want to check out. Okay, quick summary. Every branch is, let's say, separate story of your project. And you can create commits in different branches in parallel. And branches greatly simplify collaboration process when multiple people work on the same project. For example, I can create branch called BR102, make one or two commits in this branch, and after that my coworker may continue working on the same branch and create other commits. But of course for that we need to distribute our repository among different computers. And for that you can use Git hosting services like GitHub or Bitbucket. And another advantage of using branches is actually their text names. You don't need to check out specific commits by remembering their SHA-1 hashes. You just need to remember branch name and check out specific branch by its name, for example, temp, master or exp. Okay, this lecture was relatively large, and in the next one, let's finally dive into the practice and create another branch in our project. Please recap that at the moment we have only one default master branch and we have committed our changes 3 times. And that means that there are 3 commits. This one, and this one. Okay, I'll see you in the next lecture. Bye.